So today I'm gonna start here a new lesson. I'll be covering here Plotly for R 4.0. This is going to be a complete lecture on the Plotly, and this is also a live telecast for this. This is also live telecast. So you can comment if you have any question you want to ask regarding your career, and if you want any suggestion you can also let me know. All right, so I'll also try to discuss it with you here in the live. All right, perfect. So in this Plotly lecture I'm gonna take here COVID-19 data. So it has been almost a very rough year for us, this 2020, and we had seen enough of this COVID. You can visit to my repository here at github.com. There you will get this COVID-19 pre-process dataset. So this pre-process dataset have these file: country day-wise file, country-wise file, COVID-19 data clean file, and day-wise. All right. So you can simply click it here. You can click these. All right. So you will get here this country day-wise data set is having I think overall it's 10 column there. All right, I think it's 9 column there actually. There this one is also having total 10 column, and 10 column are more than 10 column. So this one is the country-wise total cases. All right, and there is another file which is COVID-19 data clean CSV file. This file you can notice there, it has total 9 column, and this one is having the data for the each day, and also it has province, state, and the country, latitude, longitude of for each of these countries. Then it has confirmed cases, recovered cases, death, and active cases. All right, perfect. Thereafter here I have another file which is day-wise file. So this day-wise file have the total corona cases for all countries, and the number of countries says that how many countries have got affected by this corona cases. All right. So let's go ahead and get started with Plotly for R. There is a link. With this link you can visit here and you will get the whole description about the Plotly. The Plotly is open source graphing library. It is used for, you can use this Plotly for R, you can use it for Python as well. If you remove this R, you will get here a whole description about this Plotly. All right, and you can also install this. There is a dash, this Plotly offer. It is kind of a dashboard. You can create a perfect dashboard. All right. So one more thing also I would like to tell you that you will find inconsistency in recovered cases. Recently, some of countries have decided that they will not report recovered cases. All right, so you will not get a correct data for recovered cases, but you will get a correct data for confirmed cases and death cases. These are the some link where it is told that some countries have stopped reporting the recovered cases. All right, so I'm using here R for Jupyter Notebook. I have a lecture series on R for Jupyter Notebook. You can also watch that. All right, so I'm using here a Jupyter Notebook. You can also create a new notebook here for R programming. In this R programming, if you type here this lib path, you will get, let me just zoom in. So you will get the library path. So there you will notice I'm using R version 4.0 here currently. By the time I'm making this video, R 4.0 is available. These are the two default library paths available for this Jupyter Notebook. This one is created by Anaconda 3. There, this one is created by us. That's mean this one is the user library and this one is the system library. So I'm gonna set here the lib path as the user library. Thereafter, these are the packages. These are the packages which we are gonna use throughout this video lecture. We have a libridate. So this libridate will be used to modify the date, and we will be using this libridate for parsing the date. We are going to use this plotly for the plot, that's mean for graphing, and then we will use here a tidyverse. So this tidyverse is used for data pre-processing. Previously I have also covered data pre-processing. You can watch it on my the Udemy course. There you can simply type there bit.ly/r4-ml. all right, so you can type this one, then you will get this course 2021 R4.0 programming for data science. These are the topics currently I have already covered on this Udemy course, but I'm also planning to add more than 20 and the 25 hours of the lecture. All right, so let's go ahead and run this one so that we can set the user library path. Thereafter, I'm installing these libridate, plotly, and the tidyverse packages. So it's going to install all these packages. Once it is installed here in your notebook, then we are going to load these packages in the Jupyter notebook. Just run it. Then it's going to attach all these R packages in this Jupyter notebook. So there is a conflict. This conflict says that these are the sum of the packages. These are the sum of functions in these packages, which is also available in the other packages. So what it is trying to do here, it is masking these functions which is available out in some of these packages like the plotly and the base and the stats. These functions are being overtaken by the functions of these packages. So you don't need to worry about that. These do a same function what it is being done here, at least here in the dplyr filter, but in the stats there you can use some other kind of the filtering. All right, thereafter I'm going to read this COVID-19 dataset. So this dataset here I'm reading this country daywise.csv file. That means I'm getting this one, country daywise.csv file. And this CSV file have the data from 23rd of January 2020 till you will notice there 30th of December 2020. All right, just run it. Now you will notice the data is loaded in the variable COVID, and with the head COVID, you will get the first 6 rows of this data set or this data frame. These are the column name for this data frame, and these are the actually the data types for these column. And it says that these column have the data type of the integer, and the country have a data type of string, and the date also have data type of string. So we do not want the date to have the data type as a string. We want this date to have the data type of the date. Then we are going to check the dimension, that's mean how many rows are there. Then we are going to convert this string data type of the date in date data type. There, if you check the head of the COVID, you will notice it is now date data type. Earlier it was the character, that's when it was a string data type. All right, let's go ahead and sort it. So this arrange is used to sort this date in the ascending order. That's mean the first date, that's mean the lower number of the date will come first and the higher date will be at the last. Then we are going to see it with the tail COVID. All right, so there you will get this country, confirmed death recovered active, new cases, new recovered, and new death. There are total 9 columns in the data set. There is the date. This one is the latest date since we are seeing here a tail. Head shows that the first 6 rows, tail shows you the last 6 rows. In the last 6 rows, we have the data for the 30th of December 2020. These are the countries. These are the confirmed cases corresponding to these countries, total death cases, total recovered cases, and total active cases. Do remember, some of countries have stopped reporting the recovered cases, so there is high probability that you will get the wrong result for recovered and active cases. Then in the new cases, this one is the new case for each day. There you have a new recovered cases for each day, new death cases for each day. Let's go ahead, first of all, plot here a line plot in the plotly. So how it is working? There you have the day-wise data. Do you remember earlier we had loaded the country day-wise data. Now we are going to load here the day-wise data. Where is that? There. So now we are going to load the day-wise data. This day-wise data is representing the data for whole world. So I'm going to just read this day-wise data. The head of day-wise data is there. It has total 10 column. And the date is having the data type of string. Now we need to convert it into a date type. Now this date is having the date type. Thereafter, I'm just going to simply plot it. So once I plot it, let me rerun it once again to just hide that warning. There, once I plot it, there you will notice. Now you will notice this plot is actually showing you the total confirmed cases. This plot is showing you the total confirmed cases here. Alright, and you will notice how these corona cases are increasing. By the 30th December 2020, total corona cases were 82.7 million. Alright, and there you will notice this day-wise data is actually a data which we had seen previously. X is equal to the date. That's mean in the x-axis we are going to put here a date, and on the y-axis we are going to put here a confirmed cases. And the type of plot which we are going to plot here, that is the scatter plot, and the mode is line. So there is the scatter plot. The scatter plot is going to plot a point by point plot, and once you put here mode is equal to line, then it is going to add those point with the line. So this scatter plot becomes here line plot. We have a same function for a line plot and actual scatter plot. So in case of the scatter plot, we do not use their mode equal to lines, but we use their mode equal to the markers. Alright, let's go ahead and see how many columns are there in the day-wise data. We have total number of columns in the day-wise data. Date, confirmed, death, recovered, active, new cases, death. So these are actually the column names. Let's go ahead and plot it for all the confirmed, recovered, and death. So there, do you see there? This one is the confirmed case. There you will notice how recovery is also increasing, but as the time is increasing, the gap in the recovery is increasing there a lot. Alright. There, but the problem is here, as the time is increasing, the many countries have stopped reporting the recovered cases. I have already shown you at the start of this lecture the link. You can visit that link. You will notice that many countries have stopped reporting the recovered cases. That is why you will see there is a huge drop in the recovered cases, because mathematically this will never happen, because once people are recovered, if 47 million people are recovered, and in the next day it is not going to happen that only 41 million people are recovered. So it's happening because of the discrepancy in the data. The recovered data is not being reported correctly. So we will see here some problem with the recovered data. Otherwise, the confirmed case and the death case is perfectly fine. There is no issue with these two cases. This is how you can plot this line plot. Now let's go ahead and see how we can style this line plot, because there are many things which we can do on this line plot. We can change the width of this line, we can change the color of this line, we can do so many things of this on this line. Let's go ahead and see. So here I'm going to provide a color range for the CNF, that's mean the confirmed cases. I'm going to provide this color. If you want to know what is the color of this, you can simply right click and just search it for wave. You will notice this one is actually the color which we had there. The another one is there, the death cases. So in the death case, you can just right click and search on the wave. You will notice this one is the death color. All right. And similarly for the other cases. Let's go ahead. Thereafter, just run it, and thereafter I'm adding a plotly. I'm adding a plotly figure there. I'm actually getting a plotly figure object. Then I'm creating here the list of color and the width. So it's like the plotly takes the parameter in the form of list. So that list is here, color equal to the confirmed cases, death cases, recovered cases, width equal to 4. And then that width we are going to pass here. And the other things are same. Don't worry about that. And the another thing also I want to add here, the axis description of the figure. There I am adding the title is equal to the total worldwide. Actually, this should be the worldwide corona cases. There you have the date and the total cases. Just run it. Now you will notice there you have got here a wider, the width of this line is actually more than what we had earlier, because we have just modified it width equal to 4. If you want to change it to anything else, you can just put there width equal to 8. Now you will notice width equal to 8 is double of width 4, what we had for the other two plots there, line like recovered cases and the death cases. Let's go ahead and see how we can do the marker styling. So the marker styling is actually, let me just run it and then you will understand it. So the marker styling is, as I told you previously, that every line plot is made up of scatter plot. In the line plot, what happened, those points get connected with the line, but there is a point. So that point is known as a marker. And there, if you change the styling of that marker, you will see a lot of points in those marker. All right, so there, you might not be able to see this, because here I think I had set the width equal to 0, but if I set here width equal to 4, then you will notice there. Do you get it? All right, it's not available yet. Let me see what we have done here. Few more thing. Opacity is also 0 there. All right, let's set it 1. Now you should see there is a, all right, so there are you able to see this? These are the dots there. So these dots are actually marker, and we have provided the color for this marker is this one, and the opacity is 1. That's when it is 100% opaque. The width of the marker is 4. You can change it to the 14. It's going to be a huge marker there. All right, but I think the 14 is a good marker there. All right, and to just pass it here, this list of this marker, there you need to just pass it here like this. There marker is equal to the cnf.marker. All right, just run it. Of course, we had already run it. So this is the total cases, corona cases worldwide. Let's go ahead and see how we can plot bar chart. Now we are going to see the bar chart for top 10 worst hit countries by COVID-19. So we need to first get the latest data, and thereafter this one is going to give us latest data. Then this one is going to do a sorting on our data based on the date, and thereafter here I'm slicing a top 10 countries. There is the top 10 worst hit countries. The first, of course, there is US, then India, Brazil, we have Russia, France. These are the top 10 countries. You can get the summary of these top 10 countries. And let's go ahead and plot here for a top 10 countries. So there is the bar plot. We are plotting here a bar plot. So in this bar plot, what do you see? In this bar plot, there is US and India. All those things are not actually well aligned. We had here all the cases, all these actually countries cases in a descending order, but here we see it in kind of a very wild order. So what happens, this Plotly does not sort it on based on the values by default. Plotly sort it based on the order of these names. So these are the alphanumeric order. So US comes in the last, that is the U, B comes first, that is the V, because in alphabetical order. That is why it is happening. So we need to make sure that it doesn't sort it on alphabetical order. So for that, we are going to create here this factor. Let me just zoom in one more time, I think. All right. So here we are going to do here the factor. Sorry, yeah, where is that? Just I zoomed in and zoomed out. Yes, there. So this factor, how it is happening, the top 10 countries we are taking, then we are converting it into a string level so that it does not sort it according the alphabetical order. Just run it. Thereafter, I get the level here. So this one is going to be the level for these bar. All right, there, just run it. Now, if you run it, there you will notice a beautiful bar plot in the descending order. So these are the top 3 countries which have most number of corona cases here. And you will notice there it's kind of exponential decrement there. So that you will notice how strong the corona effect on these 3 countries. All right, let's go ahead and see if you want to actually show these number which we are seeing here above, how you can show these number on the above of bar plot. You just run it here, you run it. There you will be able to see these numbers there. All right, so these numbers are there. These numbers come by value. So there you have this value, all right, as character, top 10 confirmed cases. So this value we are passing here. These 2 things you will notice. The text equal to value and the text position is equal to auto there. All right, that's how it is coming there. Now one more thing you will notice, we have changed here the color of these bar, and the color of these bar just got changed here, something like this. And because that color we got changed it from here, marker. All right, so this marker changed the color here. All right, so this color is changed for all the bar here. But suppose that you want to change the color of these bar individually, then how would you do that? So I'm going to create here the list of color there. So it's rainbow color there. All right, and then you just pass it here. Instead of putting a fixed color for the color, I'm going to pass here the list of color for all these 10 bar. Now you will notice all these 10 bar is showing a different color. If you don't like this color, you can use here another color, like you have here heat colors. N equal to 10 says that generate a list of 10 color. So it generates here a list of 10 color. You will notice these are the different color for each of these bar. Let's go ahead and see how we can use the subplot. So we are going to use subplot to do a complete case analysis for USA. So for that, we are going to extract the data for a US. Then we are going to arrange it date-wise. That's when we are going to sort it. Thereafter, we are going to see the first 6 rows of this data set and then the last 6 rows of the data set. So the data is recorded from the 23rd of January and the data is available till only 30th of December. Just run it. Now once you run it, you will notice. So what is I'm doing here, I'm creating a scatter plot with the line mode. That means it's line plot for confirmed cases, for recovered cases and for death cases. So for these 3 cases, and thereafter I'm adding it in the subplot there. So, and I also say that number of rows equal to 2. So that is why it is going to keep number of rows equal to 2, and there are total 3 plot. Alright, so these 3 plot are divided evenly in these 2 rows. So since 3 plot cannot be divided into 1.5, so it divided into 2 plus 1. That's how you are getting the confirmed cases, death cases, and there is the recovered cases. Do you remember you had seen a sudden drop in the recovered cases on the 13th of December and the 14th of December? It is happening because of the reporting comes from the US. US has stopped reporting the recovered cases from the 13th of December. There is the sudden drop. That is why you had got there a sudden drop in the recovered cases. There you have the day-wise case analysis with the subplot. Let's go ahead and do it. So similarly as we did earlier, I'm gonna just show here a confirmed cases, recovered cases, death cases, new case, death versus 100 cases, and the number of countries. So it says that how the confirmed cases kept increasing. There it says that how recovered cases kept increasing, and this says that how the death cases are increasing, and this number says that how the new cases are coming each day. So it's a new cases are coming each day. It's a huge there. And there you will notice this one is actually the deaths per 100 cases. So this says that what is the death percentage. Alright, so this says that what is the death percentage. You will notice the death percentage is quite high around the April 29. So by the month of April and before the May, the death rate was quite high. It was almost 6 to 7%, and that time people were afraid a lot that it is going to, cause a lot of harm here. But the later on, as we got the experience with the COVID and the doctors had developed a better medicine combination, then the death rate kept decreasing, and currently we have death rate somewhere around the 2. Still, it is a huge, and we are hoping to get the vaccine soon so that we can live our life as we were living before the corona era. Alright, let's go ahead and just plot this whole plot in the another way. So this whole plot, I have just plotted it in the bar plot, and this bar plot is really looking cool here. Alright, and you have here very good plot here. This one is the bar plot. So this bar plot here says that I have just changed here the type equal to bar, which I had earlier there. Type equal to, I had a scatter plot with the mode equal to line, but now I have here type equal to bar plot. Now I'm gonna see here with a scatter plot for death versus confirmed cases. Just go ahead and run it. Now you will notice here the scatter plot have the confirmed cases and the death cases are there. Alright, these are the some of the small the cases are reported there. US is there, the highest number of confirmed and the death cases. There you have Brazil, there you have the India. That is how you can plot the scatter plot for the death versus confirmed cases. So it has here the data equal to top 10, x equal to the confirmed cases, y equal to the death, type is a scatter plot, mode is the marker. So there do you notice there, if you put here a mode equal to lines, you will get the connecting lines between these plot. I think, well, it's not gonna work here. So the moreover, because here we have, alright, so you can of course put it here once again, the markers. Alright, earlier we had used mode equal to the lines, it was working there. And since this is not the correct data there, so it might not work properly. Alright, thereafter here, once you move ahead, we have here a pie chart. Let's go ahead and see how much each of the top 10 countries are contributing in the corona cases. So we have here a top 10 countries, list of these top 10 countries. In these top 10 countries, we are going to see what percentage they are contributing in the corona cases. You need to just run it. There you have the data. Level is country. That's mean we are going to use the level as the country. values, we are going to use confirmed cases as values. And we are going to also use here this type is equal to pi. All right, so this one, the type equal to pi, that means it is going to be a pi plot. The text info we are putting here level plus percentage. That's when we are going to put here the level plus the percent of the contribution. There you will notice US is having the most number of contribution in the corona cases. It's 36%. If you just consider the top 10 countries corona cases, India have their 19.1%, Brazil have their 14.2%, and the rest of other countries have a less number of cases. India and the US alone causing here more than 50% cases. Thereafter, you have here the another plot where we are going to analyze the death percentage ratio. In the death percent, US, now the Brazil is on the second place and the India is the third place. So the moreover, you can say that the total death rate is less than the US and Brazil, what we have in India. And then we have the Italy, UK, France, and then there is the Russia. All right. Finally, let's go ahead and plot this donut chart. Donut chart is like a pie chart, just we add here whole equal to 0.6. Though this whole says that how much we want to fill as blank area. All right, so this one is the donut chart. There you have US, Brazil, so the same data which we had earlier. And there is the donut chart for the confirmed cases. This one was for death cases. Now we have it for confirmed cases. All right, perfect. So this is all about in this lesson, and I would request you, if you have any question, please ask me. All right, and one more time, I would like to tell you that you can just simply type it here, bit.ly or a bit.ly/r4ml. All right, to get the whole, get my course on Udemy. So you can simply type this there. All right, let me change it into a marker mode perhaps. So this one is the course link where you can get the R4.0 programming for a data